All right, good morning and welcome to the last week before spring break. So, because we had some snow and some ice and we're behind and I'm changing things around a little bit in terms of trying to get everybody caught back up, you'll notice that this week looks a little less busy, and I'm going to have everything due at the end of the week so that you go into spring break with nothing due in this class, hopefully. So, the other piece then is this is a great week if we can get everybody back on board. I will remind you that if I post a solution to a problem, that you can in no way turn that back in then at that point. So this is a class where I really need everybody to turn stuff in on time, and I know we've had some odd startings and some weird things this semester. So we're going to work on trying to get everybody caught back up here. All right, so this week, really quickly, so we're looking at strings. We are not going to get the entire chapter done this week. So when we come back, we're going to also be working and looking at strings and slices and all different kinds of interesting things. We're also going to give you a way this week to begin to be able to solve problems and store those results, and they don't go away as soon as your computer program runs. So we have a lot of stuff in here, so make sure you've done the reading. We have a couple of programs that I've introduced. So you're going to see a couple of these that I've added some additional text in here. So these are actually out of another book, but we're going to look at them and see how some of these things work. So if you click on one of these links, it links into, well, slowly it will. So it links into another textbook we've used. And this one is written in another, for Python. It's a little older, but it also has some really quick ways to deal with this. So we're going to also look at that one, trying to hopefully make this make sense. All right, so your assignment then this week is you only have 3 programming assignments, and 4.1 is actually just a practice. 4.2 and 4.3 are the assignments. If you look at the discussion board, I've even taken the discussion board out for this week. So there is no discussion board due this week. So we only have the couple of assignments. So let's take a look at some of our content here. So we're looking at the idea of strings. And we've talked a lot about strings. It really is a set of characters. It can be numeric data, it can be text data, it can be escape characters. So it's really just a group of items. Well, we're going to try to figure out if we can manipulate those strings. And when we first started, we didn't have any way to do that. We had a string, and we could set it equal to a variable. So we could say, somewhere on here I have my idle. So we could say name equals, and so that's a string. We don't do anything with it other than assign it. But if I now wanted to print, I've assigned it a value. It takes it back. But to be effective, I think I'm going to have to do some other things with that. Because in our world so far, Bradley, if I have it with a capital B, is not the same as, so if I said name2 equals, so to you and I, if I said, if name is equal to name2, so this is just a really quick example. So if I run this, I would think that it's going to spit out hello. Because in my brain, Bradley and Bradley, it's the same thing, but I forgot to capitalize. But they're not. And you'll see that if I try to run this, it's going to hiccup and say, no, there's nothing to run. It's not going to output anything because they're not equal. Now, if I were to come up here and I were to change it to not equal, you'd see that they're different. So maybe I want to look at how do I sort these, or sort a list and do some other things. So I need a way to be able to manipulate inside of those strings. And luckily we can do that. And Python makes some of this really very easy to do. So we're going to look at some of the easy ways we can do it. So we're going to extract or be able to pull pieces of a string out. And so maybe what we're looking for is we want to categorize everything in a list that starts with the letter B. And I have a whole lot of data that has words in it, and I just want to grab things that start with B. Well, we can show you how we can find a way to do that. So here's where we start. And that is this idea that that string is really a set of values, but they have a position. Yeah. All right. So that position, we can extract it and we can utilize it based on that piece. So if I come back to my idle and I say, all right, come on, all right. So the first piece I need to do is I can figure out how long this string is. And so I can actually use that. So I can do a print, and I can do a length, and I can say length of name 2. And when I do that, it's going to say, hey, there's 7 characters in there. So, but remember, it starts 0, 1, 2, 3, 4, 5, 6. So in this case, it would stop at position 6. If I change this, and that's one of the beauties here, is I could reassign this. So I could say name, which one do I want to do? 2 is equal to now I've changed that significantly. And so now if I were to run that same statement, print length of name 2, it's going to give me a much longer list. It's going to give me a length of 40. And why I want to point this out, notice there's a lot of spaces in this particular string. Spaces consume a spot, just like if we had a character in there. So, in fact, in this one, notice high there, that space is actually forming a character. So our length is 40 characters long here. So we could actually use that to then extract individual elements out of this if we wanted to. So they have an example here. So we're using subscripts, and the way we're going to show you a subscript is with these square brackets. So above the enter key on your keyboard is these little weird square brackets. So we can try those. So if I wanted to do another print, and I said, I really want to print, and I only want a piece of that, so I'm going to print name 2, but I only want the first letter. See if you can see it. It's down at the bottom of the screen there. And when I did that, it printed R. Well, that's not the first letter in Bradley. Why did it do that? Well, remember, we start with 0. So if we come in here and we do the same thing, and instead of 1, we put our 0, now it's going to take that first letter, and we can actually pull those individually one at a time. So there's a lot of ways we can do that. So here are example in this book. They created one called Alan Turing, and they said position 0, position 3. And here we ran into an issue because they went beyond that. So we can see what would happen. That big. So if I did this very same thing, I wanted to print name to, and I know that this is 40 characters long. I already ran that test. But if I wanted to print character 40, notice what's going to happen. Because I'm calling character 40, it's actually the 41st item in that string. And it doesn't exist. And it's going to come back and say, oh, no, we're out of range. So if I wanted the last one, I would actually have to do $39, because 39 is the top value and we count by 0, and we get R, which is what we should have from up here. All right. So we have some other shortcuts and other things we can do. We can actually go backwards. And so this is where it gets a little strange. So when I did the 39th character, or position 39, 0 through 39, the last one, I can actually use negative numbers and do something very similar. So if I did a print, so I did a -1, it also prints that same character. So it's another way we can get to that last character in our string. The advantage to doing the negative, if I'm looking for the last character, even if I've done a length, that it avoids me making that mistake of grabbing something that's just a little bit too long because I forgot what it was or the string is shifted in some way. So negatives will also, so I can also go backwards. So I could do this all the way to the end of this. Name to -40. And let's see what happens. So -40 is all the way at the left. -1 is all the way at the right. So weirdly, if you like to count by ones, you could do it on the negative side and just do it completely backwards. So it's one way we can do that, but it's the same set of characters. We're just referencing them from the right and from the left. So we can use that length command. We can find out some information. We can use this square brackets we've talked about, or a subscript, and we can reference a specific character in there, whether it's the 3rd character, 7th character, whatever it is we want to do. And that leads us to then the ability to do some other things. So here we're showing a loop, and that loop is outputting the characters then one by one. And so we could build something very similar. So come back over into our idle. So we already have a string here called name2, so we're gonna use that. And oftentimes we use x or I or index in range. And so here we just take the length of name2. So what that's going to do is say a range from 0 to 40 in this case, or 39 because we're going to count one off. And then we can do a print. Oh, what did I do? I missed somewhere. Oh, I didn't put a colon after it. My bad. For index in range length name2 chunk. There we go. All right. Let me move this up just slightly. Try to let you guys see it here. All right. So we can create this loop that will then run, and we can, instead of using a solid value in here, we could actually create that where it's got a index value, and then we could print our list out this way. We could scroll through every item in our list. So I'm going to start a new file just because it's a little easier to run these in batch, I think. And so I'm going to set that equal to name equals doesn't really matter what, and then range of length of name and so now anything inside of there, so if I did a print, and in this case maybe I want to show the number I'm going to print, and then I'm going to print name index. So now let me run this real quickly. I'll have to assign it some kind of a name. So now it took my string and it put it, so we scrolled all the way through there. And so it's a handy way we can look through an entire string of data. So, and notice it even got, when I put this on at the end, I have a space there. So after the on, I have a space. Well, it indexes that and says, yep, that's space 32. Or if I look at my length, so if I printed my length, I should have a length of 33 characters in there. So if I added that after my loop, print length of name, now it's going to say, hey, you had 33 characters in there. So kind of a handy way to be able to scroll through our data. So even though it's a string and we can't manipulate it as a number directly, we can actually start to get that data and manipulate it as a string. So here we're going to look at taking a string, and we're going to actually be able to do a slightly different manipulation. So in this case, we're going to introduce you to something called a slice. So if I look, oh, come back here, Idle. There we go. So I have this string, and I think it's a great one. We're gonna play with it here a little bit. So rather than, I'm going to just put an asterisk out there and an asterisk here and take those lines out. So here's our string, and I know how long it is. We have that print statement. Well, now I want to be able to extract some characters from this. So I'm going to do another print string and then print name. And instead of putting in a direct number, I'm going to use my friend the colon. And so let's see what colon or 0 colon does. So these all have a slightly different set. All right. And so if I run this, it says this is a string to experiment on. It gave me back the entire string. So if I leave it open on either side, so, and you can experiment, we could change that to 7. And we could run it. So it slices it at that position and just grabs from that point on. We could take it from 7 to position 10. So 7 to 10, so 1, 2, 3, 4, or 0, 1, 2, 3, 4, 5, 6, 7. So it slices it after 7. It gets a space, and then it gets the A, and then it slices again. Okay. So we can slice and dice, and you can do it with the negatives. So if I leave out a character, I slice to the entire end of it. So there are some handy ways we could do that. So you could print name, and I only want from 15 through the end. it's an easy way we can slice and dice and grab those. And you can then assign them, so you don't have to print them. So the other thing I could do is if I wanted to grab out a piece of that, instead of a print, I could set that to name2 is equal to, and it's going to take whatever that slice is and assign it to another character. So this gives us the ability then to do some searching and do some other things, so we can do something kind of exciting. So let me get back out of here for a minute. So back in our Blackboard here, assignments. So there we go, loaded in the other page. Okay, so slowly, come on, Cengage. So there's a lot of string manipulations. So here we can take some quotes and we can also manipulate them in some other ways. So this particular program, so we can recreate something very similar. We actually get some other items that I think are kind of interesting. So I'm going to grab a section of this or recreate a piece of this. So chunk. Let's see if this will actually work. File new. This is saving me from retyping, except it didn't work. All right, hang on a second. It brought it all over as one big long string. So I don't know if this will actually save me anything or not, but we'll see. With my inability to type occasionally, this might still be quicker. So notice when I copied and pasted, it just made one big long string. Okay. So now that I'm over here, I know that for 5 computers, comma, print. Print. Now the weird thing, if I actually just tried to use this, it would actually run, because Python doesn't really care about all those spaces, although it makes it easier for us. Python doesn't care. All right. Now it looks a little better. All right. So we have a quote, and that quote is, I think there is a world market for maybe 5 computers. Well, we know now that's not really great. So here we have the original quote. So we say, all right, we're going to print that. But we have some other tools to manipulate text. And so one of them we get is something called these dotted notations. And so now we're starting to see, this is kind of a Python only. There's other languages we can do similar things, but it takes a lot more effort. If I want to take that entire quote and I want to make it uppercase, I can simply do quote, so the name of our string, dot upper, and it's actually going to convert that. But notice I have to have an open and close parenthesis right here after I use that. That's really just saying, hey, I'm sending in something to a function. So if I had nothing else than this piece, it would print out the original quote and print it in uppercase. We can change it to lowercase. We can do title case, in other words, where every capital is there. And we can also even use this to replace pieces of our string. Python is so smart, or at least so human-like. If I say quote.replace, it will search for 5 and replace with millions of. So the other thing to note in here is, this is kind of my pet peeve when we're working in Windows especially, although there's some other ways around it, is putting in this blank input at the end to hold that program open. So let's save this and run it and see what happens. Let's see if it really works like I think it should. All right, a little small here, make that a little bigger. So here's our original quote. I think there is a world market for 5 computers. Here we put it in uppercase. Here we put it all in lowercase. Here we said a title. So in other words, it took every word and put it capitalized. And here we actually replaced it, but only in that print statement, which I think is interesting. So here we replaced that for millions of computers, but when we go back and we actually printed our original quote, it hasn't changed. We didn't make any substantive change. It only changed it temporarily so we could print that. So a lot of different things we can do with quotations, we can do with text, and they're not necessarily that hard to do. Here we have that dot notation, and the book over that we're using primarily doesn't show you this handy trick, and I think it's kind of one of the more fun things that you can do there. So, and in fact, if you want to go through and look on it, in here it tells you then and explains all the pieces of the code again. And then finally, at the end of it, and one of the reasons I like this book was it gives you then some of the string methods, we're going to call them, or string tools. So you can even do one called swap case. So where you're changing, if it's got uppercase, it becomes lowercase. Capitalized title, you can strip out white spaces if you needed to. You can use the replace. So, and you even get this ability to limit how many replacements you have, which I think is really handy. All right, so this week, programming exercise 1, I'd like to take a look at it really quickly if it'll load. Come on, Cengage. Yeah, all right. We already bought your stuff. We don't need more advertising. So 4.1 is a program we're going to look at here really quickly. Come on. So in this particular case, so we're not graded on this one, but we need to be able to create it. So we're doing a little bit of encryption. And so those of you that are taking some of my other classes, we talk about encryption and cybersecurity. What we're looking at is something called a Caesar cipher. So if I look up cipher, so maybe I need to find some information. All right. So a Caesar cipher is a shift cipher. All right. So maybe we can make it more explainable if we look here. So here we said, all right, here's our plain text. And notice down here is our plain text. But what happens is it rotates around. So there's the end of our alphabet. We've shifted it, in this case, 1, 2, 3 characters to get from A to there. So A is now equal to X, B is Y, C is Z, and now D is A. So it's just a shift where we slide them over. Well, my guess is you guys all did this in kindergarten, grade school, somewhere where you wrote down the alphabet and you wrote a letter beside it. Well, that's very similar. You're just rotating those. So if you had a wheel, and if you've seen like Dante's Inferno and some of the movies like that, they've got ciphers like that where it's just rotated around a wheel. So it's not horribly complicated in your brain here, I hope. But we need to figure out how we can do that then with a code. So some of it's pretty easy to do. So we know we could create, and we'll just call it plain text. We're going to say that's equal to an input. Please enter a string to encrypt. All right, so that part's pretty easy. We also need one other thing out of here. We need that rotation key. So that rotation key we can derive, and we're going to say it's whatever number, and so we're going to let them put it in. So we might call that key equals, and because we know we want it as an integer, I'm going to go ahead and put it in as an integer. Input, please enter a numerical value for a key. So the hard part then is done. So we get the input from the users, and we can test it over here. We say, yep, is everything going to work so far? Please enter a key. Oh, I did something wrong. I don't know what yet, but I'm sure it's in there somewhere. Please enter a key, and I caused it to hiccup. Great. This I should not be allowed to type and talk at the same time. Input, please enter a string. Key equals integer of, oh, hang on. This is why I shouldn't be allowed. All right. So now we can test it and run it. We don't have to have the whole program there. So enter a string. All right, and a numerical value of 3. So if I do that, now I've got some data in there. And so now I need to figure out how can I get that data encrypted and moved in. And I know that we have that distance. So we're going to have to do a little bit of manipulation. So I might call that one my cipher text. And I'm going to first set that as blank, just in case we run it multiple times and it does something weird. Well, one of the things that we can do is we can create a loop of some sort. And so we could get the length, and we could do a while loop. In this case, one of the things we could do is a for loop. So we know that our plain text is going to have a certain length. So we could do for, pick a number, x, or we could do index, or whatever we want to do, in, and then we can actually just say plain text. So this is kind of a handy way to do this, because it's going to go all the way through and index every piece of that. So if you wanted to test this, one of the things you could do is do a print statement, and you could say print plain text x, and I hate using just x, but it works for our purposes here. And if I run this now, in our tiny little window over here, except I did something again. What have I done there? Plain text x. Oh, I put 2 of them on there. Gee, many Christmas. I can't apparently put parentheses in today. All right. Try it again. Quick brown fox 3, which isn't going to do anything. And then string indexes must be integers. So why did it not like that? So maybe I will have to convert that to an index or an integer for it to do that. So that's what it's saying there, is that it doesn't like the x value. So I might have to put a line in to make sure that that is directly converted to. So in which case I could do x equals int of x. And that would then convert that directly to an integer. So if I can do that and I can get this list, I can then think about how am I going to increase that. So I need to think about that string of text. And maybe the easiest way to do it is with Excel. So in Excel, I'm going to put up my index positions in this line. So index, so I'm going to say that we are 0, 1, 2, 3, 4, 5, 6, 7, whatever we have in there. So I'm going to start with so here's my plain text, and here's my cipher. So my plain text says T, H, E, space, quick, we're not going to get the whole thing in there, but that's my plain text. And if I go into the ASCII and see what those values are, I can actually then use that to increase those. So I also need to think about what is an ASCII table. So how do I represent those values? So I'm going to cheat and go grab an ASCII table so I can look at them. So an ASCII table, let's see if Wikipedia has one. Always handy. So Wikipedia then has this list somewhere on there. Should be an entire list. Aha. So here we have our list. So what we're really doing is we're saying, all right, I'm going to find T, and so T is going to be in our printable characters. So if it's a capital, it's one value. If it's lowercase, it's another value. So I'm going to find T, which here is 164, and then I'm going to put that in, and I'm going to add 3 to it, and so I'm going to move them each direction. So in other words, if I have H, I'm going to move down to the character 1, 2, 3, and it's going to become a K. So this is kind of our template. But we need to figure out a way, is there a way in Python, so we're going to have to slice up that string, is there a way to get the values that are in an ASCII table? So we have to figure out a way to add 3 to this, 3 to this, 3 to this, 3 to this character. So we need a way to return those ASCII characters and then rotate through. So is there a way? So here's what I'm going to do. There's a book and there's all this stuff, but let's see what happens. Python return ASCII value. So, because reading the book takes a lot of time, here we can sort and we can say, oh, there's something called a function called ordinal. Oh, all right. And then we also have one that might be kind of handy. So here the character does this. So this is where we can experiment and try to figure out if that works or not. So we have ord and we have character to put it back. So let's do something weird. Let's just not even play with that yet. So we're just going to X that out. Before we know we can go through that list, and if we can go through the list, we can probably do this. But let's see if we can find out the value in this ord, what it can do. All right, so I'm going to say denull value equals, And we're going to just put in ord, and I'm going to put in, let's put in T, capital T. And let's see if this runs. So we'll print ordinal. So we can put some of these tools together. So print ordinal value, trunk run. Aha, so T is equal to 84. So hey, that works. So we can do something with that. Because now, if I know that the value is 84, so now let's see what happens. So if I would take ordinal value plus, or let's do it this way, equals ordinal value plus our key. So now we've changed that, so we've added 3. And so then we need to use our CHR to bring it back the other way. So we need to print what that character is. So we go back and look, see it says, all right, character of 97 equals A. So let's see what happens if we do that. So we want to print character, and we want to do it of ordinal value. All right, I really should pick some shorter ones in here. So we're putting some tools together, kind of arming our toolbox here. So our string is whatever it is, doesn't matter. 3 is our key. Huh. All right. So we actually printed then W, and I also printed that value because I wanted to see what it's changed to. So we went from 84, which we knew that was our T, to an 87 and a W. Huh. So there's some hope that we can do this. We can put this in a string and do those exchanges one at a time. All right. Now that I said that, there's one more strange thing we need to look at. So if I go back, hopefully I didn't close it. I might have. All right. So our ASCII tables, so they have all these printable characters and all these fun things. And it generally stops at 127. So all these are strange characters up above that we don't normally see. But it starts at 0, goes to 127. What if, and maybe we even wanted to shorten it because we know that we don't want the brackets. Here's the problem. So here we have a small w or a small z in your text. We used a really big index. We used 10. It's going to come down here, and it's going to be down here in these unrecognizable symbols. Or even worse, maybe we said, I want a key of 200, and it's even past the limits of this table. Because remember, this table is built on the powers of 2, and we have 256 spots, and that's it. If it goes past there, we're going to get that out of range error. So we're going to need one more thing in there. And that we're going to need to figure out how we could subtract and move back around. So if I hit greater than 127 with my math, how do I reset that and make that a circular function and reset it back to 0 plus that value? Does that make sense? Hopefully. All right. So I know that there's a lot of strange pieces in here. But once we get this one done, and we'll work on it some more in class on Thursday, but once you get this one done, it actually leads to you being able to do come on, open up. So the graded assignment then asks you to do this. Come back. This one says I'm going to do something very similar. I'm going to enter coded text, and I'm going to go a distance value, and I'm going to have to come back and unencrypt it. So it does exactly the opposite of that program we're working on right now. So what you'll find, though, is that coding is very similar. So if we can get these concepts down, you're going to find that works very similarly. And then if we look at 4.3 and loads and loads and loads and loads and loads, do. Come on, load. All right. So 4.3 then says we're going to modify these scripts, and we're going to actually create a program that both encrypts and decrypts those values. So we start with 4.1, we figure out 4.1 and 4.2, and then 4.3 is really combining those into an assignment that says I can both encrypt data and decrypt data and see what it does. So that is our assignments this week. All right. I am also going to introduce some solutions to some of the materials, or a possible solution for some of the things that have went in the past. Once I post those, I can't take that assignment anymore. So this is a great time to start getting caught up if for whatever reason you're not. So email me, make sure I'm aware of where you're at and what you're doing. And hopefully we'll get through these really quickly. We should get most of that actually done in class on Thursday, kind of seeing what's going on. And so hopefully everybody will get these done. We'll go into spring break. Everybody can have a week without any thought about programming, and then we come back, and then we hit the second half of the semester. All right. Any questions? All right. Let me pause this.